Today we introduce two more definitions: atomic statement and molecular proposition. Atomic statement. What do you mean by atomic statement? Any statement or proposition which do not contain any of the logical operators or connectors are called atomic proposition. It cannot be split into simpler proposition. Molecular proposition or molecular statement. A proposition with connectives is called compound proposition or molecular proposition. Compound proposition or molecular. Atomic proposition is nothing but any proposition should not contain any of the logical operators is called atomic proposition. Molecular or compound proposition is nothing but a proposition with connectives. Connectives means logical connectors or logical operators is called compound proposition. So truth table consists of column and row. So how we are going to frame a truth table? A number of columns depends upon the number of propositions and connectors used to form compound propositions. The number of rows in a truth table are found on the basis of proposition. If there are two simple proposition, then it should be 2 power 2, which is equal to 4 rows. If there are 3 simple proposition, then 2 power 3 will be equivalent to 8 rows. Likewise, suppose if we have n simple propositions, the total number of rows will be 2 power n. Okay, we should have some ideas to frame a truth table. Suppose if the proposition contains 2, suppose we have two propositions P and Q. So how we are going to frame a table, truth table? Already we know that truth table consists of column and row. How we are going to frame a column? Column is nothing but number of propositions. Number of columns depends upon the number of propositions. So here we have how many propositions? 2 propositions. So column means number of 2 propositions is 2. Therefore number of columns is 2. So P and Q. So how we are going to frame rows? Suppose if the preposition contains two simple propositions, the statement contains 2 simple propositions, then how we are going to frame a rows? 2 squared is equal to 4 rows. So we have 4 rows, 1, 2, 3, 4. Okay, 4 rows. So how we are going to write these column and rows? We should have some method. Suppose we have 2 simple propositions, then we are going to have 2 columns. In the first column, it should follow 2 squared, which is divided by 2, which is equal to 4 by 2. 4 by 2 is nothing but 2. That means 2 trues followed by 2 false. So first column should have this 2 rows T followed by 2 false. So how we are going to write second column? 4 divided by 4, that is 2 squared divided by 4. This is equivalent to 1. So 1 true followed by 1 false. 1 true followed by 1 false. True, false, true, false. Likewise, we can frame a table. Okay. Suppose we have 3 simple propositions. How many prepositions you have? 3. So number of columns will be 3. So P, Q, R. Number of columns 1, 2, 3. Okay. So how we are going to write a row? So here we should have some method. We should follow some method. 2 cube divided by 2. That means 8 divided by 2, which is equal to 4. So 4 trues followed by 4 false. So you are going to write 4 trues. T. Then it should follow false. 4 false. Okay. So you should have this way. Second column will be used in this manner. 2 cube divided by 4. That means 8 divided by 4, which is equal to 2. So 2 trues followed by 2 false. So here 2 trues followed by true false. 2 false. Okay. So how we are going to write the third column? So 2 cube divided by 8, which is equal to 1. one true followed by one false. So one true followed by one false. True, false, true, false. Likewise, we are going to frame a truth table. Is it clear? So if you follow this, then this is very easiest to follow. So don't change this order. You should stick on to this method. Okay. So next we talk about the logical operators. Negation. So conjunction. So what we have, conjunction means any two prepositions combined by the word and to form a compound preposition is called conjunction. Suppose we have two simple prepositions P. P is nothing but 12 is divisible by 3. Divisible by 3. The another preposition is Q. 3 is a prime number. 3 is a prime number. 3 is a prime number. So how we are going to write a conjunction of the two statements? So for that I am going to use the conditional connectors, that is logical operators. P conjunction Q. P conjunction Q means we can use the symbol P and Q. So we can use the letter and. 12 is divisible by 3 and 3 is a prime number. 3 is a prime number. Okay. Here the connectives are, the statement is and. Sometimes we, instead of using and, we can use yet, but. We can use but, yet, nevertheless also. Okay. Yes. So how we are going to frame a truth table for conjunction? Already I told you, truth table consists of column and row. Number of preposition depends upon the number of columns. How we are going to frame a row? Suppose we have two simple preposition, 2 squared by 2. That means 4 by 2. 4 by 2 is 2. 2 trues followed by 2 columns, 2 false. Similarly, we can write the number of rows. So here only two simple prepositions. The truth table for conjunction is P and Q. So here two prepositions, only 2. 12 is divisible by 3. 3 is a prime number. So 3 followed by 2 false. 2 false. And second column is 1 true followed by 1 false. So how we are going to write the conjunction of these two statements? And that means if two of the preposition is true, then the conjunction of two statement is true. Otherwise, it is false. Okay. So 2 of the preposition is 2. If both the prepositions are true, then only the conjunction truth value is true. Otherwise, it is false. Okay. Next one, disjunction. Disjunction. So we can use this symbol for disjunction as this one. We can call it as or simply we can call it as join. So here also we can assume the two simple prepositions. So the truth table for disjunction is PQ. So 2 true followed by 2 false. 1 true followed by 1 false. Okay. So how we are going to write the disjunction of these two simple prepositions? P disjunction Q. The truth value of any of the preposition is true, then the disjunction of the statement is true. Otherwise, it is false. Okay. Otherwise, it is false. Any one of the preposition is true, then the disjunction of the statement is true. Otherwise, it is false. Okay. Third one, conditional statement. Conditional statement. Conditional statement, or we can call it as implication statement. Implication. Okay. So how we are going to write the truth table for implication? So once again we have two simple preposition P and Q. The first column will follows 2 trues followed by true false, and second column is 1 true followed by 1 false. So the conditional statement of these two preposition is P conditional Q. If P is true, then Q is false, then the conditional statement is false. Otherwise, it is true. Okay. When P is true and Q is false, then the conditional statement is false. Otherwise, it is true. Okay. So for the conditional, we can use a different alternate way to express conditional statement. P conditional Q is also same as P implies Q. P implies Q, P only if Q, Q whenever P, Q whenever P, Q if P, Q if P, Q is necessary for P, Q follows from P, Q is a consequence of P. So here we shall avoid the word implies. Implication is totally different from implies. Okay. So here we can avoid the word implies because it might be used in different contexts in the future statement also. So the next one will be biconditional statement. The truth table for biconditional is biconditional. We can use the letter biconditional. So P biconditional Q. The truth table for biconditional statement is, so here also we have P, Q. So P biconditional Q is, so once again we have the same concept, 2 true follows by true false, 1 true followed by 1 false. The biconditional statement of P biconditional Q is, if both the truth value of P and Q have this identical truth value, then it is true. I repeat once again, both P and Q have identical truth value, then it is true, otherwise it is false. Both P and Q have identical truth value, identical means same, okay, truth value, then it is true. So here P is false, Q is also false, therefore it is true, otherwise it is false. So for this also we have a different way to express biconditional. P if and only if Q, P only if Q, P if Q and P only if Q. Okay, P is necessary and sufficient for Q. If P then Q, if P then Q, and conversely, P if and only if Q.